The Big Bang did not happen somewhere. It did not happen at a point in space that you could locate on a map. It did not happen in a specific direction that you could point toward. It did not explode outward from a center the way a bomb explodes outward from a detonation point. The Big Bang happened everywhere simultaneously, including exactly where you are right now. The space you are currently occupying, the air around you, the ground beneath you, the atoms that make up every cell of your body, was part of the Big Bang. Not in the sense that the explosion reached your location, in the sense that your location was the explosion. Every location was the explosion. There was no outside. This is not a simplification for a general audience. This is what the mathematics and the observational evidence actually describe. And almost everything you have ever been told about the Big Bang, the explosion, the starting point, the moment before it happened, the question of what caused it, is either incomplete, misleading, or a question that physics currently has no answer to. By the end of this video, you will understand what the Big Bang actually was, what happened in the first second that no other period in cosmic history has come close to matching, why the question of what came before it may be permanently unanswerable, and what the evidence is that confirmed it happened at all. The term Big Bang was coined in 1949 by astronomer Fred Hoyle, and he meant it as an insult. Hoyle was a proponent of the steady-state theory, which held that the universe had always existed in roughly its current form, with new matter being continuously created to fill the gaps left by expansion. He used the phrase Big Bang dismissively in a radio broadcast to describe what he considered an absurd alternative hypothesis. The name stuck, and Hoyle was wrong. What the Big Bang describes is not an explosion. An explosion involves matter moving outward through space from a central point. What the Big Bang describes is the expansion of space itself, the metric expansion of the universe. Every point in space moving away from every other point, not because objects are flying through space, but because the space between them is growing. The analogy most physicists use is a balloon covered in dots being inflated. From the perspective of any single dot, every other dot is moving away. There is no center dot. Every dot is equally the center and equally not the center. The surface of the balloon is all there is. There is no point on the surface that is the origin of the expansion. What we call the Big Bang is the extrapolation of that expansion backward in time. If every point in the universe is currently moving away from every other point, then at some moment in the past, every point was closer together. Further back, closer still. Until approximately 13.8 billion years ago, when the observable universe was compressed into a volume smaller than a proton, a state of density and temperature so extreme that the physics we use to describe normal matter completely breaks down. That initial state is what we call the Big Bang, not an explosion into empty space, the beginning of space and time themselves. The first second of the universe contains more events than all of the subsequent 13.8 billion years combined. At time zero, approximately 10 to the power of negative 43 seconds after the beginning, the four fundamental forces of nature were unified into a single force. Gravity, electromagnetism, the strong nuclear force, and the weak nuclear force were indistinguishable from each other. The universe was a state of perfect symmetry at a temperature and density that no current theory can fully describe. What happened next was a sequence of symmetry-breaking events, moments when the unified force split into distinct forces, each of which released energy and changed the fundamental nature of what the universe was. By 10 to the power of negative 36 seconds, the universe underwent a period called cosmic inflation. In an interval so brief it has no meaningful comparison in human experience, the observable universe expanded from a volume smaller than a proton to a volume approximately the size of a grapefruit. Not slowly, exponentially. The expansion during inflation was faster than the speed of light, which does not violate relativity because it was space itself expanding, not matter moving through space. Inflation explains why the cosmic microwave background is so remarkably uniform. Regions of the sky that are causally disconnected, too far apart to have ever exchanged information, have the same temperature to 1 part in 100,000. Without inflation, this uniformity has no explanation. With inflation, it follows naturally because everything in the observable universe was once in causal contact before the inflationary expansion separated it. Inflation also explains where structure comes from. Quantum fluctuations, random variations in energy density at the quantum scale, were stretched by inflation to macroscopic scales. Those density variations became the seeds of the large-scale structure of the universe. The web of galaxy filaments and voids that defines the cosmos today is the direct descendant of quantum noise from the first fraction of a second. By 1 microsecond after the Big Bang, the universe had cooled enough for quarks to bind together into protons and neutrons. By approximately 3 minutes after the Big Bang, the universe had cooled enough for protons and neutrons to fuse into the first atomic nuclei: hydrogen, helium, trace amounts of lithium. This process lasted approximately 17 minutes before the universe had cooled and expanded too much for fusion to continue. Everything heavier than lithium was made later, in stars, in supernova explosions, in neutron star mergers. The carbon in your body, the oxygen in your lungs, the iron in your blood. None of it existed after the Big Bang. All of it was forged later, in stellar furnaces and scattered by their deaths. For most of human history, the question of how the universe began was philosophical or religious. Physics had nothing to say about it because there was no physical evidence. That changed in 1929. Edwin Hubble was measuring the distances and velocities of galaxies using the Mount Wilson Observatory in California. He found something that the scientific community was not prepared for. Every galaxy he measured, without exception, was moving away from us. And the further away the galaxy was, the faster it was receding. This is Hubble's law, and its implication is direct. If everything is currently moving apart, then in the past, everything was closer together. The universe is not static, it is expanding. And if you run the expansion backward, you arrive at a beginning. The second piece of evidence came in 1965 by accident. Arno Penzias and Robert Wilson were engineers at Bell Telephone Laboratories in New Jersey, attempting to eliminate noise from a microwave antenna they were using for satellite communications. They found a persistent background signal that appeared uniform in every direction regardless of where they pointed the antenna. They tried everything to eliminate it, including cleaning pigeon droppings from the inside of the antenna. The noise persisted. What they had found was the cosmic microwave background, the thermal afterglow of the Big Bang itself. When the universe was approximately 380,000 years old, it had cooled enough for electrons to combine with atomic nuclei, making the universe transparent to light for the first time. The light released at that moment has been traveling through the expanding universe ever since, stretched by the expansion from visible light into microwave radiation, arriving at our instruments from every direction simultaneously. A photograph of the universe when it was 380,000 years old. Penzias and Wilson received the Nobel Prize in Physics in 1978. The third pillar of evidence is Big Bang nucleosynthesis. The prediction from the physics of the early universe is that approximately 75% of the ordinary matter in the universe should be hydrogen and approximately 25% helium by mass. The observed ratio in the oldest stars and in the intergalactic medium matches this prediction with extraordinary precision. These three independent lines of evidence, the expansion of the universe, the cosmic microwave background, and the primordial element abundances, converge on the same conclusion. The universe had a beginning, and that beginning was approximately 13.8 billion years ago.
The question everyone asks is, what happened before the Big Bang? It is a reasonable question. Everything that exists has a cause. Everything that begins has a preceding state. The intuition that the Big Bang must have had a before is deeply embedded in how human cognition works. The problem is that time itself began with the Big Bang. General relativity treats time as a dimension of space-time, not as a background against which events occur. In the same way that there is no location north of the North Pole because north is defined relative to the pole, there is no moment before the Big Bang because time is defined relative to the Big Bang. This is not evasion, it is the actual content of the mathematics. However, general relativity breaks down at the conditions of the Big Bang itself. A complete theory of quantum gravity, a framework that unifies general relativity with quantum mechanics, does not currently exist. And it is precisely such a theory that would be needed to describe what, if anything, preceded the Big Bang. Several proposals exist. The Hartle-Hawking no-boundary proposal suggests that time near the Big Bang behaves like a spatial dimension, eliminating the question of an initial moment. The eternal inflation hypothesis suggests that the Big Bang was a local event within a larger, eternally inflating multiverse. Loop quantum cosmology suggests that the Big Bang was a bounce, a transition from a preceding contracting universe that reached maximum density and rebounded. None of these are confirmed. The question of what preceded the Big Bang may not be one that physics can answer at all, because the evidence from before the Big Bang, if any existed, would have been destroyed by the inflationary expansion. The boundary of what we can know may be the Big Bang itself. 13.8 billion years ago, the space you are currently occupying was compressed into a volume smaller than a proton. In the first second, everything that governs the behavior of matter and energy separated from a single unified force into the four distinct forces that structure all of physical reality. In the first 3 minutes, the first atomic nuclei formed. Every atom in your body was forged in the aftermath of that beginning, in stars that lived and died before our solar system existed, scattering their contents into the interstellar medium that eventually collapsed into the sun, the earth, and everything on it. You are not a product of the universe, you are a rearrangement of it. The same atoms, the same forces, the same physics that governed the first second of existence governs every electrochemical reaction in your nervous system right now. The Big Bang did not happen somewhere else. It happened here, in the space you occupy, 13.8 billion years ago. Subscribe to BrainDrop if this kind of content changes how you think about where you are. And tell me in the comments, if we confirm tomorrow that we could detect what happened before the Big Bang, what do you think we would find?